And I was thinking more about these two monoids that are connected, and I found out another structure. So this is what I want to show.
Nice. The context here is your Arabic numerals and Roman numerals code,
yes,
right?
Exactly.
Yeah.
This is in your Erlang implementation?
Yeah, but this is the implementation of Arabic and Roman numerals.
It's in that same repo, but it's like tangential a little bit, right?
Yeah, and this is this was an example that Greg told us to build. So, but it's very for me. I learned a lot how this this computational way of constructing programs. So I have almost the same final representation of Arabic and Roman numerals. They are just constructors, and they're really the generators of the language of the numerals. And addition is just a monoid. These two classes are to combining addition and like any numerals to in addition representation or addition language. And I found out this structure that I can use for both Arabic semantics and Roman semantics, and also for addition semantics. So this structure, I'm building with the help of this structure, I'm building this initial representation. So this what I want to show you. So before I had this recursive part inside the structure as part of the data type, and now I have extracted this recursive part, and I can define with this helper structure this initial representation.
Hey, hold on a second. I've got a question. In the old version, what was that recursive part? So this is data Arabic numeral, right? And there's the A0, A1, etc. for all your regular digits. What's that? Yes. What is that first one for again?
This AN is just a representation of collection. So this AN constructor means I will have a list of all itself, or a list of itself. So you can have like multiple digits.
Yeah, okay, that's what I was going to say. That's for multi-digit numbers, right?
Yeah.
One thing that I'm realizing now that I don't know if I realized last time is that with that structure, that doesn't have to be a list of like A0, A2, A4, A5, whatever. Like you could have other lists inside of there.
Yeah. And then this is exactly how can you put more than one digit. But
why did you do it that way, and instead of separating the types into like a list of the numerals and then just the numerals themselves?
So I needed to have this recursion. So you can have multiple digits. But also now I wanted to have these two different things as Greg was explaining. So I hold this like a calculus like a calculus builder. So you can say, okay, these are my generators for my language, and this is the collection that I will collect. And in my previous example, all of this is one data type. Like for Roman numerals, the code is like almost the same, but it's like a different structure. But now I have both of these and Arabic and Roman digits are defined with the same structure. The base structure is just the generators of the language, nothing else, not how you collect it. How you collect it is specified in different type.
Oh, cool.
And I like it because it's semantics is really how Greg was explaining. You have generators and you have collection.
Mm-hmm.
And I'm using the same thing for addition semantics. So here I'm using the same thing. This is like some A of generators combined in multiset.
And the multiset is like the add-ins, right? The things you're going to add together.
Yeah, this is the collection. Yeah.
Nice. What's addition pair for?
Addition pair is when I want not only evaluate as an integer, like all the summation, but also I want to have a string so I can see all of the whole expression.
I see what you're saying.
So
it'll say, so like in addition to just getting the answer is 10, you'll also see like 5 + 4 + 1.
Yes.
Okay.
And this is the main point. I found this structure which I can use in all three monoliths. And and I was looking at this structure and it looks familiar, but I didn't realize immediately. But this is exactly free monad structure.
So what's your comment there? Computational calculus representation consists of the recursive part, which represents a collection of terms, and then the generator is term generators.
Because when you look at, for example, when you look at implementation of this binary of this binary operation on Arabic numerals, I'm pattern matching on this recursive part, on this collection, and how this collection is built, how you combine how you combine this these terms of your language. And if you have some semantics as syntax erasure, you can use this structure to say, okay, if I have a generator, then I can pattern match on my constructor in my language, and I can express whatever I want. So in a sense, this is very similar to my previous implementation, but now I have additional structure, so I don't have to encode it always in each of my language. And this is exactly how you use free monad. You encode all of your constructors and then you match it on these constructors. And
so on the right side here, that code's almost identical, but on the right side where you said like instance semigroup AN, that's on the right side, it's all like specific for the Arabic numerals, but on the left side it's written in the more general style that also works for the Roman numerals.
Yeah, but here I'm giving implementation for this Arabic numeral structure.
Oh,
So,
yeah. Okay.
Yeah, but it looks totally the same. Like this is implementation, previous implementation for Roman numerals, and it looks almost the same.
That's pretty cool. So, so it's still like, can you show us how it run it once?
Yeah, sure. Can I just say? So I can say something like this: v plus 5. And yeah, this is the structure of when you have evaluation and a string. Like evaluation, two different evaluations, and the final result.
So when it's printing the parsed expression and it says actual like Roman or Arabic 5 plus 5, that's Haskell printing out like integers, right? Whereas on the right side, that's printing out that 5 is a string and that v is a string.
Yeah.
Yeah, cool. Very nice. Yeah,
so,
that's like super abstract. I don't know if I fully wrapped my head around all of it yet.
Yeah, and I want to find out how I end up with the free monad here. So
yeah, I wonder. I think you need attention from someone that's a better Haskell programmer than me to really.
Yeah.
That's awesome.
Thanks.
Can you do IV plus 5?
Sorry?
Can you do
any like oops, plus here. Yeah, I can mix and match, and yeah.
Amazing.
Yeah, and I want to show you the parser is a little different, but on purpose I made it like this. I created like a map of constructors and string representation. Like, you know, this 5 is constructor, and this character is string representation of character representation. And I just have this this list of constructors, and I'm creating all of these parsers from this list, and I'm just saying like a choice of all of this is a parser. So is the parser for one digit, and combining this digit with space with nothing, you get like a digit, Arabic digit, like numerals. And for Roman numerals is very similar. It's also a map from constructors to character. It's like the same. And what I have in mind is, these terms looks to me as a tuple space.
Oh.
But in Arabic numerals you have only you don't have this recursion like in Roman, but you have some kind of way that you're searching for in some map from some name when you want to make when you want to combine terms in Roland, when you want to make a column. And in the same way, in addition, you don't have this, because whatever you get from this double space, you will always find something that you can combine and sum.
Yeah, right.
But the mechanism is very similar. So I'm thinking how to extend this, but because recursion is a problem.
Do I sense comma events coming in your interpreter soon?
Yeah. I've started but I don't have
Oh, nice.
nothing. Yeah, I also now I want to apply this to rolling, what I show you with numerals.
Mm-hmm.
And I separated rolling in different parts. Now I have this process semantics, which is just input-output. I have a reflection semantics, which I'm not sure this is something I like, but this is a reflection semantic, which is a while and quote, from one world to another. Mm-hmm. And this is just a monoid semantics with nil and par. And I separated variable semantics and ground name semantics. So all of these things now I have separated. So because I'm trying, to build this more extension, extension. I'm saying this correctly.
Mm-hmm. Yeah.
And
row calc with variables and ground terms. Yeah.
And now I started to build something that is like a context that I can match on this, and this is really related. This is really related to this paper I found out how to build meta circular interpreters without reflection language. And in this paper, they say that you can have some kind of context with meta continuation that you can play with and done all these things. So that was what I'm looking for.
Yeah. So, wow. So it looks like there's a lot here. So you have a function called substitute. This is going to be for when you do a com, right? It like replaces.
Yeah, this is all substitute function, and this match function is not correct. So I will not talk about it.
What's it supposed to do? It's like your pattern matcher?
Yeah. I want to populate bindings from when I have two rolling terms. And if you remember, you were talking about this, how you go to, you have two terms and you go to all of this, recursive structure, and you're trying to match everything. Mm-hmm. And from this matching, you get your bindings. Mm-hmm. So yeah. I want to do the same thing. Yeah.
Nice. Yeah, I was for a while there. I was wondering why were there two different sets of bindings? But it should have been clear from the names. You're binding some name variables and some process variables, right?
Yeah. But I want to have this, but it's not necessary. And maybe it's not only that it's not necessary. Maybe it's too hard to work with both of them. But for now, I want to have both of them. So.
Yeah, totally. I mean, Kyle did both of them in the Scala implementation, so I think it's possible.
Okay.
Like I think you can match, when you do a pattern match, you can extract both name variables and process variables.
Okay, say again.
I think when I like in the co-ops Erlang interpreter that mostly Kyle wrote, it's possible to bind both name variables and process variables when you do a successful match.
Oh, I see.
I'm pretty sure that's true.
Yeah.
Oh, sure, yeah, totally it is. Yeah. If you just pattern match on a send, right? Like you've got a name there as the channel and a process as the message, and you can pattern match on both of those.
Yeah. Yeah, and because of that, I made one more change. Now I have special constructors for like a term process and term name. So I can easily have term process with a variable, but also I can have term name as a variable. So if you remember, my previous example was a little different. I used this special type, NP.
Yeah, I do
construct.
remember that. Yeah.
But now I changed this, and I'm using these special constructors. Not only one constructor, but special constructors to both of these.
Nice.
I'm just exploring, how this will work.
Yeah. Yeah. It's pretty cool that you're exploring doing it a couple different ways, so you really get a good sense of like what's easiest to work with or think about, and what enables different ways of expressing things.
Yeah. I'm definitely learning, how how can this be done in Haskell and how this works in Erlang.
Yeah. Have you looked at the Scala code much? The implementation of Erlang?
Yeah, I'm looking at some of the code, and yeah, I'm definitely trying to figure out how this works in Scala.
Yeah, nice. Yeah, I didn't take much inspiration from it because I just have such a hard time reading it.
Yeah. Me too.
Yeah.
And I know that they definitely don't have this two representation of a name of variables.
Oh, they don't?
No, they
Oh.
have only one representation. If you see a protobuf, it's only one representation. So it's
yeah.
everything is converted to only one, and so I'm thinking about that as a solution, as an easy solution. You convert everything.
But at least at some point, they still distinguish them, because you can get these error messages like name variable used in process context or something.
Yeah.
But yeah, I agree. You're right that that's not reflected in the protobuf.
Yeah, and maybe this is maybe this happens before, but I'm not sure it's part of the parser. Maybe not.
There's something called the normalizer. I don't know exactly when that runs. Isaac posted a really nice Atlassian article about how term normalization works that I thought was pretty interesting. But yeah, I don't know like when that stuff runs or where that name variable and process context message gets detected. Probably before like the actual evaluation starts, I guess, right?
Yeah. I'm thinking that maybe even in the parser.
Yeah.
Because in my parser, I can definitely catch this, and this would be parser.
Oh, you could catch it in your parser.
No.
But if you wanted to
No.
Yeah. Because you would need to know, like when you went to use a variable, you would need to know whether it was a name variable or a process variable, and the parser doesn't know that yet.
Yeah, exactly. I mean, it knows, but well, parser can detect this, but I didn't want to. Well, I can have different variables if is in another position. This is like crazy, but you have a process variable A, but you also have a name variable A in the same program.
Yeah,
and
right.
I can do this. I can do it with this parser. I don't think this is like a clever idea to have in your language.
Yeah. Is that really a feature?
Yeah. But it's definitely possible because they are living in two different worlds. This is like a name variable. This is process variable.
Yeah, that's interesting. Oh, you're saying even in the same scope, you can have one of each.
Yeah. Let me show you.
Wow.
Like in simple example, and I can have x and y, and now I can say sending on x this is a name. So this should be, oh no.
That seems fine and normal.
Yeah, but it should be replaced with bound variables because I want to use this x in a different way. Oh, sorry, my example not working. Yeah, but idea is that I could use this x in this way, for example. And both of these x's will be different, because they are they are parsed with different part of the parser. So
right. So the first one is a name variable, and the second one's a process variable.
Process variable, yeah.
And then, like, based on the context where you use that on the right, you know that you need a process there, so it just grabs the correct x. Oh, that's
if you use this, this will be like using the process variable, and if you say just x, this will be this will be process variable. If you use with the star, this will be name variable.
The name variable. Yeah.
But this is crazy, having.
Yeah, that's a pretty nice way to write some obfuscated code, though, if you ever need to do that. Yeah. All right. So, well, do you guys want to call it a day?
Yeah, sure. Yeah. It was an interesting talk about your grandpa consensus. Yeah.
I hope to understand it more, and interesting on this. On all the Haskell too. I feel like I'm just going to slowly absorb Haskell from watching you program it.
and program in Rust, in Haskell style.
Yeah, right.
It seems to me Grandpa is more or less just an exercise in separating out the notion of finality, sort of artificially.
That was the most interesting part to me.
I'm sorry?
That was the most interesting part to me, so the separation.
Right, so, right. So in terms of implementation, it really doesn't need to be separate.
Yeah.
Okay, if you can see whether your algorithm supports finality at the earliest possible time to get Byzantine safety. So that people aren't considering choices that are never going to win.
Yeah, and I'm thinking that from recent examples that Greg shows, this separation can lead maybe to have Oracle that can change over time or with messages.
Yeah, that's talking about evolving.
Yeah. So that you can have different constraints in different environments, like a different consensus mechanism in different networks or different. Yeah.
Now you got me thinking about if we've abstracted the finality away from the block production, maybe we can have multiple. Remember my crazy idea about having multiple instances of Casper? Now I'm thinking about multiple instances of whatever your finality gadget is running on top of the same block production mechanism.
Yeah.
I don't really think that's useful anymore after we talked about it the other day, but it's still kind of interesting to think about.
Yeah. And yeah, if you have some kind of dynamic consensus, maybe you can do something like that. Yeah. Cool.
Alrighty. Well, I'll see you guys soon.
All right.
See you.
Okay.
Thanks,
bye.
Bye. Thanks, Jim.
Yeah. Thanks as always.